So is the recording started? Let's check. Okay. So a quick revision for yesterday, for last time. So we did chapter 11, IPv4. We say IP addresses are used to identify devices for communication. Without any IP, no communication. It's like ID. If you don't have an ID or passport number, we don't know who you are and we cannot help you. So one IP, one device. And we said this is an example. Can you hear me properly? Can you see my screen?
Yes, sir.
Okay, cool. So we say this is an example of an IP. If it's South African ID, SA ID, it should be something like 7909 14 and 444 and 4444, something like that. So these IP addresses, we can classify them in 3 groups: class A, class B, and class C. So how to identify a class A? We always check the first block. If the first block is between 0 and 127, we see it's a class A. For class B, if the first block is between this, and for class C, also this. Did you copy the screen to check to study? Then, so we know how to classify IP addresses. And we also say that we have private IPs and public. Private addresses are not used. We are not used for internet. We are non-routable. It means the router will not send them to the internet, and we use them for labs or internal stuff. So for class A, if you see an IP address starting from 10.0.0 to 10.055, it's a class A private IP address. It doesn't go to internet. You cannot assign that to a PC to go to internet. The same for class B, it's between this range. Class C, this range. Now, if anything doesn't fall in these brackets, we have public IP addresses. We are used to go to the internet. We are routable. Now, we also check the structure of an IP. An IP address has a network part and a host part. So we check that for class A. The first block is for the network and never change. It's to identify the network. And anything else we can assign to host. Like if your network part is 20, you can assign 20.001 to someone, 20.002, 20.0010, 20, you see. So the network part doesn't change. It identifies the network. For class B, we see the first 2 blocks are for the network. The last 2 are for the host. And for class C, the 3 blocks in each. After that, there is something called default subnet mask. So for class A, because the first block is for the network, we are all ones, and we say /8. /8 means it means we have 8 ones. For class B, the first 2 blocks are for the network, so 8 plus 8, 16. So if you see /16, it means we have 16 ones. And for class C, the same thing. We also check that a definition of subnet mask. So a subnet mask, it will identify in which network a host belongs to. So any IP address comes with a subnet mask, because with that subnet mask, we identify in which network that host belongs to. So if it's the default subnet mask, it means we have only one network. You see. As soon as the default subnet mask changes to something, it means we divided our networks in smaller networks, like we did last time. So if we have a default subnet mask, it means all hosts belong to the same network, only one network. Okay, so now we know default subnet mask, we know the definition of subnet mask. Now we can do an exercise. So I did explain to you, I did give you this example, and you say it's a class C because of the first block. And we know the default subnet mask for class C is /24 or 255.255.255. And we check also for other ones. Now subnetting, or dividing a network in smaller network. So if you divide them and you have smaller network, for each smaller network, we'll have first valid host. This one is bigger than always. This one is what? 14. This one also should be 14. So each smaller network will have a first valid host, last valid host in a broadcast. And we did an example. So we said, this is a host, an IP address, 192.168.10.12/25. And the question is, in which network, or in which smaller network, that IP belongs to, and from that small network, find the first valid host, last valid, and broadcast. So when you have a question, you have a guideline, a guidance. First thing first, what is the type of, and what is the class of that IP? I'm going to put it here. So that IP is a class C because it starts with, in fact, I'm going to write it here. It's a class C because it starts with what? 192. Yeah, when we identify the class, step 2, identify the default subnet mask for class C. And you say it's /24. It means I have 24 ones. 8 plus 8 plus 8 and 0, 0. Now, step number 3, because you see /25, it's no longer the default. If it's the default, it's fine. It's only one network. But if it changes, it means that network has been divided in smaller one. So to find them, how many bits did I borrow? Because normally the standard is 24. Now I see 25. So we need to find how many bits we borrowed. So you do a 25 minus the standard is 1. So I did borrow. This is my network part. Class C, the first 3 blocks are for the network. And I did borrow 1 extra to make 25. I borrowed from the host. Now we need to identify how many smaller networks I have. To find it, we have a formula. You say 2 to the power of bit borrowed.
Sorry, sir.
Yes.
You have stopped sharing your screen.
Okay. Thank you very much. Yeah, thank you. So always, please let me know. Thank you so much. So all good now?
Yes, we good now.
Okay, thank you. Thank you very much. So now we need to identify how many smaller networks we have. So the formula is 2 to the power of bit borrowed. So 2 to the power of, here we borrowed only 1 bit. So 2 to the power of 1 is, we have now 2 smaller networks. Sorry. Okay, I can put it back there. We have 2 smaller networks. Now, we need to list the smaller networks based on the magic number. So how to find the list? So because it's a class C, the first 3 blocks of the IP of that IP won't change. It will identify the network. So to find the smaller network, you take the first 3 first, and you add a 0. So we start with 0. Now, we need to add the magic number to find the remaining. If the magic number is, let's say 10, so it will be 0 plus 10 plus 10 plus 10 plus 10 plus 10. So how to find the magic number? You see here, we see we borrowed only 1 bit from the host. Then we do our table and we put that in here. You see, we borrowed only 1. So we put it here 1 0 0 0, and that 1 falls in 128. It means 128 will be the magic number. It means now we do 0 plus 128, and we have our 2 networks. Our 2 smaller networks. Now, for a smaller network, we need to find first valid host that we can assign to a PC. A last IP address I can assign to an IP to a device, and we broadcast. So to do that, you list first your 2 networks that we have, and we take the first network. To find the first valid host I can assign to a device, I do the network and the last part plus 1. To find the broadcast, you take the next network IP minus 1, and to find the last, and you do your broadcast minus 1. So you do the same thing for this guy. Now, from the question, so first, just have a look on this one and we continue again. You can stop me anytime, you can ask questions. There is no problem. Okay, now that we have all info, we come back to our question. Our question is, this IP belongs to where, to which network? 10.12. So the first smaller network, the range is from 10 to 1 to 10 to 126. That's the first smaller network. It's like a room number. So I did divide my house in two. In part A, I have room number 1 to room 126. Now here our question is say room 12. So where room 12 falls in, it falls in this range. So it means it belongs to that network. For now, you might ask yourself why we do all these things. If you work in a company, getting an IP address is expensive. So you need to take that IP and cut it in smaller ones. So it's like you have a full chicken and you need to eat it for 7 days. You say, no, I'm hungry, I'm going to eat the whole chicken in 1 day. Then the next 6 days, you'll get hungry. So you take that whole chicken, you cut in 7 parts, and every day you eat 1 part, 1 part, 1 part. So you have 1 IP address, then you do what? You can divide it, you can divide them. Maybe this one I'll assign to finance department, this one to call center, the other one to marketing, you see. So if you see /25, it means how many ones? 25 ones, huh? So /25, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25. 1, 2, 3, 4, 5, 6. So now if you convert this one in decimal, is 255.255.255.128. You see? So in the exercise, you can see such IP with the subnet mask, or you can see the same thing. Instead of slash, it will be 255.255.255.128. It will be the same thing that you'll face in the exam. So this one is equal to this. Have a look and we continue.
Hi, Max, I have a question.
Yes.
I don't know if the question is gonna sound strange or what, but I'm gonna ask it. From my understanding, this IPv4 that we're doing now is static IP.
Yes.
It's a manual static IP address that we are addressing IP addresses to certain computers. Let me say it like that. So if I use a star topology, maybe 2 switches. I'm using 2 switches. Now I'm using class A until 8. How can I say it now? For class A, it ends up until 8. No? If I'm correct.
Okay. Let me stop you. Please forgive me. In companies, we only use class C to make life easier.
Oh, okay.
Yeah,
Which
class
means it's a
C.
broad. It's a broader.
Yeah, yeah. we always use class C. From time to time, for bigger companies, class B. Class A, we usually don't touch them.
Oh, that is for smaller companies or smaller offices or so.
Yeah, class A is more for MTA and telecom, the big companies, and to manage big stuff. You see, because we have a lot of hosts that we can use. Okay, let us continue. And so another question?
No,
Yeah, so
that
for,
is all. That from my side. It's all
yeah,
from
so
my
for
side.
company we use class C. Yeah. So for exams, you'll see an IP like that with subnet mask /25. It means 25 ones, or we convert this binary with 25 in decimal. We're going to do a second example. Hi, what is it? I didn't copy. Okay, I'm going to copy the. But this one is. I was directly on the IPv6. Okay, this one is page 65. Okay. Me, I like taking notes and making summaries. It helps me to do quick revisions. I'm going to copy the other two guys. And so we did number 1. We're going to take number 2 until number 3. Hi. So what is number 3? Okay, it's fine. Page 65. Yeah, 65. Okay. So we did example number 1. I'm going to give you another example here. Example number 2. To which smaller network this IP address belongs to 192.168.10.80. No, let's say 85 slash 26. So when you have such thing, you check what the subnet mask. So what type of IP is that? Is it class A, B, or C?
Class C.
Who said class C? Is it Mrs. Kotiane?
Yes, sir.
So you said class B.
Class C.
C or B?
C. C for Kotiani.
For Kotiane. Kotiane. That sounds nice, eh? Kotiane. Thank you, congratulations. So why do you say class C? Kotiane. Wow, that's nice.
Because it starts with 192 and
Very good.
yes.
Very good. the first block falls in the bracket for class C. So for class C, what is the default subnet mask for class C?
It's 255, 255, 255, and 255, 255, 255, 255. I'm not sure about the last digits.
That's 0.
It's 0.
So congratulations, you are there. So we're going to use the guideline, guideline, okay? So the guideline will help us. The guideline says what? First step, identify the class. Oh, what's that? This Windows 11, it's quite annoying me. Identify. Oh no. Identify the class. So Mrs. Kotiani says class C. Why? Because of the first block. This one falls in class C bracket. So we did identify the class. Now, step 2 is what? What is, okay, class, the default subnet mask. So what is the default subnet mask of class C? It is /24, or as she said, 255 or 1111. Okay, or 255.255.255.0. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So I'm going to put very small, this one. Yeah, even 8. Yeah. Let me bring back. And this one, I put a bit smaller. And this one, yeah, so you see. So all this part is for the network. That's why we say, if you convert all of them in binary, in decimal, we are all 25525. So this is the default. Now, we see that here the subnet mask is /26. It's totally different from the default one. It means something extra has been borrowed. So we are at 25. Now we are at 26. How many has been borrowed from the host? So here you see bit borrowed or borrowed. Bit borrowed. What do? We do with 26 minus with 24. So 26 minus 24 equal 2. So we borrowed. So from here, we added 2 extra here. So I'm going to put a bit bigger. We borrowed 2 extra here. So in red, it's 24, the normal one, the standard one. But now we say 26, so we borrowed 2 extra. We borrowed here, 1, 1. These are the 2 extra that we borrowed. Now, because we borrowed from the host, it means our network has been now divided in smaller network. Now here, how many smaller networks? So we did 2 to the power of bit borrowed. It will be 2 to power of bit borrowed. We did borrow here 2. 2 to the power of 2 is equal to 4. If you take your calculator, 2 to the power of 2, it will be 4. So we have 4 smaller networks. 4 smaller networks. Now, oh, what's that? Now here, we do what? We need to list or identify these smaller network. Identify these, smaller networks based on the magic number. So I do my table. I put 128. Why it speaks in red here? 64, 32, 16, 8, 4, 2, 1. Now I check the host portion, because I did what? I did borrow 2. So I start, you see, 1, 2. Anything else, I can put 0, 0, 0. So I take from the host here on top here. Now, how to find the magic number? I take the last one. So the first one falls in 128. The second one falls in 64, and it's the last one. It means my magic number will be 64. So now if we need to list our networks, so we take this IP, because the first part is, because it's a class C, the first 3 groups never change, because we're going to identify the network. So to list my smaller networks, I always start with 0. So who can tell me the second one? The second one is it will be 0 plus the magic number. So 0 here will be 0 plus 64 is 64. The third one, and because we say we have 4 smaller networks, I have 1 here, the second one. So to find the third one, I do 64 plus 64. So the magic number will help us to identify my smaller networks. 0 plus the magic number, plus the magic number, plus the magic number. So I put it here. So 64 plus 64, you take your calculator, 128. So 64 plus 64 will be 128. Now the last network, smaller network, it will be the same thing, 128 plus the magic number. See? So 0 plus 64 plus 64 plus 64. 128 plus 64, 192. And I'm done. These are my 4 smaller networks. So take a break, have a look on this, and we continue. You can copy the screen. So first thing first, you must identify. So you follow the steps and the guidelines. Now that we found all these smaller rooms or smaller networks, so inside we need to find the first valid address I can assign to someone, the last and the broadcast. So I'm going to copy this one. Pair. The smaller network. Find first valid host, last valid host, or last host we can assign and broadcast. So it's easy. So from here, we need to find first host, last host, broadcast. So to find the first host, we do the network. And so I'm going to put in red. So I take the net to find the first valid host. I take the network plus 1. Oh. Sorry, my guy is freezing here. Okay, to find the first host, I do plus 1, the network plus 1. To find the broadcast, I take the next network minus 1. Yeah, so it will be 64 minus 1 is 63. And to find the last valid host, I do the broadcast minus 1. should be 62. So this is how we identify this stuff. We do the same thing for the second one. So we copy everything here. We come here, we paste. So when you have a network like that, the first valid host is the network plus 1. So here will be 65. To find the broadcast, I do the next network minus 1. So 128 minus 1 is what? 127. And to find the last host, valid host, is broadcast minus 1, 126. You see? So this is how we find stuff. And we do the same thing for all of them. So now our question is what? This IP 192.168.10.85. So 10.85 it's where? So who can tell us? 10.85. It belongs here or here? Mrs. Kotiani, can you help us?
10 dots.
85. So here, the first one, you see, I can start with 10.1 until 10.62. I can assign these numbers in my group. So 10.1, .2, .3, .4 until 62. Group number 2, I can start with from 65 to 126. So here we say 10.85. So 85 is in which group? This one or this one? 85.
It is in group 2.
Group 2. Because group 2 start from 65 and will end to 126.
Isn't group 1, so let me check.
So you see? So 85 is somewhere here. You see, no? It's hidden somewhere here. Because here is 1065 until 10126. So 85 is between this range. Are you okay, Mrs. Kotiane? Are you happy?
Yes,
or
I'm
not?
okay, sir. No, I'm okay. It's in group 2.
Okay, group 2. So now we have the answer to our question. I take back the question. Normally, you should continue with the 2 remaining, in which or to which this one be smaller network, this IP address belong to, and you say this one belongs to smaller network equal to it belongs to this team, to this network. See. Now, if you have slash 26, you can convert in binary. Slash 26 is how much? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now here we have 24, 25, 26. Then you convert this one in binary. All ones, if you convert in binary, is what? 255. All ones, 255. All ones, 55. Now here you put in your table. So the first one, 128 plus 64. So if you put in your table, the first one is 128, the second one is 24, and 192. So in a question paper, we can say this IP slash 26, or it will be same thing if we say 192.168.10.85, but this one 255.255.255.192. The same thing. So take your time, have a look for 2 minutes, and we continue.
Hi, sir.
Yes.
Can you please throw back up a little bit? Thank you, sir. Right there. No,
Let me
that's...
put you can copy the screen, then you can take your time to. Oh. Is it too small or not?
That's fine, sir. Thank you.
Yeah. After that, you have this part also. Okay, we are done with chapter. This is what you're supposed to know. If you go in EtherCAD, we have too much information. You can get lost. So you can, if you know how to do this, then you can add a bit of EtherCAD, you can do a bit of quiz. is, but if you know what we did Monday and today, we just need now to practice with some packet tracer stuff. So today we're going to do something also quick called IPv6. So we know IPv4. Now we're going to IPv6. We see that IPv4 is almost finished because so let's say the population is growing. There is no more length. We now have to use the sea to make a plan to build some artificial island or what to accommodate everyone. So IPv6 is also an IP address, but much longer. So I'll make it very simple for you guys. You see, we are late, and some years ago, 10 March. Now we are 20. We are almost 2 weeks behind. Okay, so here I'll try to make it very simple for you. Why I say part 2. Part 1 is what? Actually, this one I was looking for. But anyway, we did it. Okay, let's quickly do. So why we need IPv6? We say IPv4 is almost finished. We don't have enough for everyone, so we created. So IPv4 and IPv6, we can still stay together. It's not one will disappear and no. So if you want to use both in a company, you have a technique and some techniques. We call them. I'm going to show you. Okay, it's not here. If you want to use these two technologies together in a company, I'll show you now. Yeah. Oh. I need to find my, yeah. So if you want them to stay together to coexist, we have two technologies and 3, dual stack. You configure your devices or your router for both to work together. Or tunneling, the IPv6 will go via IPv4 network, or translation. But we most use is on top. You keep both in the same network. You do a small config in the router and done. Now, how to present IPv6? So IPv4, it was 4 blocks. IPv6 is 8 blocks. You see, 1, 2, 3, 4, 5, 6, 7, 8. And each digit is an hexadecimal. So you see here D, B, it's hexadecimal. Each of them are hexadecimal. And you know that one hexadecimal, if you convert in binary, it's 4 digit there. So this is an example, and have a look of IPv6. Okay, can you still see my screen?
Sir.
Okay, so these are examples of IPv6. Now, so you see, sometimes you have a lot of zeros up and down. Why you cannot just remove them? So we can make them shorter. For that, we have rules. Rule number 1, omitting leading zeros. Only leading. So for example, if you have 0, 1, AB, you can change it to 1AB directly. If you have 0, 9, F0, the leading only, 9, F0, you can remove it, you can omit. Not the back one, the front one. You can remove. 0, 0, AB, you remove the leading zeros, you can make it short AB. So this is an example down here. 2001, it's 2001, there is no leading zeros. 0 dB8, we can remove a 0, you see. So if you have 4 zeros, you can remove the first 3, you keep 1. 1, 1, 1, there is no zeros, and you see. So check this one. So this is rule number 1. Rule number 2, double colon. This one. So if you see a series of 0, you can remove them and put double colon. So you see here, for example, 0, 0 here, you can put it only 1, 0, only 1, 0, only 1, 0. And because the following and we are together, you can remove them and put this one. So please read this one, check the example. Okay, this is some rules that can help us to make them short. Now also we have, remember for class IPv4, we have class A, B, C. So here we also have some types of IPv6. So normally we have three blocks, 3 families. We have unicast that we'll be using a lot, multicast, and anycast. So we have 3 big families. So you can have a look and continue. Okay, after these 3 families, the most used will be the first one, unicast. So in unicast, we have these 1, 2, 3, 4, 5, 6. We have six types inside unicast. But we have only 2 we use a lot. Global unicast, it's like a public IPv4 that we can use to go to internet. And we have link local that is valid between you and me, between the PC and the switch or the PC and the router. It's valid only for these 2. So the 2 most we will use global unicast and link local. You can also check these ones and we continue. It's coming here. Okay. So we said we have 3 families. The most used is unicast. In unicast, we have 6 guys there, but we use only 2, global unicast and link local. Simple, done. So now if you have an IPv6 and we say we have 8 blocks now, the first 4 blocks is to identify my network. It doesn't change. The last 4 blocks we can use to identify, or we can use them to assign to host. So we have 2 parts. The first 8 blocks, so the first 4 blocks, the prefix or to identify the network. And the last 4 blocks we can use to assign to devices. I try to make it very simple for you, be a lot of stuff. Very simple for you. Okay, this one I want to touch. So link local, you see it valid between 2 devices only. It's something very simple. And when we use some lab, you will see that. Try to make it very simple for you. So now if we need to configure IPv6, we go to the global config mode, interface gig. We type now IPv6 address, and we type the IP address we had in the question paper. It's always /64. We have 64 ones. So these guys, it will see always /64. Then no shutdown. So have a look. Okay, we'll do them in the labs. So if you need to assign via packet tracer, we come here, and this is an example of what we do. The /64, we put the 64 here, and we put the IP address here. This one is for the default gateway. It will be given, all info will be given in the question paper. Yeah, so you can check here. Okay. Now for the link local, and so what we did, it was the first and the first one. We say we have 2 that we use a lot. Global unicast address, GUA. So this is what we do for GUA. Now we're going to do how we configure link local. So in this slide, we did GUA. Now we're going to do LLA, link local. So what we did, yes, question?
I want to ask, why are we not using the loop back?
Yeah, look back because, so you see, PCA, if he doesn't want to go to the internet, he still needs to communicate. This is how IPv6 has been created to make life easier. Instead of always going to the internet, it can talk to the router only. And from there, depending on the config in the router will decide what do you want to do. So it's a plan B. I don't know why we do that, but yeah, it's something like that.
Okay, thank you, sir.
Yeah. Okay, no problem. Okay, now how to configure LLA? We go to the interface again. So thank you very much for your question. For IPv6, each interface has two IPv6 addresses, the GUA plus the link local. It's always like that. It's the way it is. If you ask me why 1 + 1 is 2, my friend, it's the way it is. So any interface for IPv6 has two, the GUA, Global Unicast, and the link local. So you can check how it's configured. You can read everything and check. Okay, so all these things, we'll do them in some labs. Okay, this one we want to do. I'll skip it, not important. So for a device to get an IP manually configure, it's what we did till today. Or we can have a server, a device to automatically assign them for us. We call it a DHCP server. So it's a device in my network that will automatically assign IPv4 or IPv6 addresses to my host. You can do the configuration for that. We'll touch that a bit later, CCNA2. Okay, all these we can skip. Multicast we can skip. I want to make it very simple for you to be ready to use. Okay, so this one is good. So remember, the IPv6 has 8 blocks, and we said the first 8 blocks is the network, and is the first 4 blocks for the network. The last 4 is for interface ID that we can assign to host. The last 4 we don't touch. Let's focus on the first 4. On the first 4, the first 3 will identify my company number. And the one remaining, and so we have 4 now, the first 3 will never change. Identify my company. And the one remaining will be the subnet. It will identify, for example, okay, IT department will get number 1, finance department number 2, marketing department number 3. So number 3 and assign some numbers to them. So this is an example. If we need to do some subnetting for IPv6, it's less difficult than IPv4. This is how it is. So you can have a look, and we'll do a lot of labs. It will be easier. Okay. Yeah, so you see here, this is an example. The first three is to identify my company, for example, CPUT. Now, if I have accounting department, I can assign a subnet. If I have IT department, you see, so here, the fourth one is the subnet, or yeah, is to identify a group. And from there, I can assign, inside, I can assign numbers to my PCs. Okay, always we'll have time to do them. Yeah, so again, this is an example of configuring IPv6 interface, IPv6 address, you add the address, no shutdown, exit. You go to another interface, IPv6, no shutdown, exit. And again. So have a look on this one. Okay. And we are done for IPv6. I made it very simple. I gave you exactly what we will need for our labs. Now, at a later stage, when you feel very comfortable, you can get extra information in NetAcad. If you have some videos, feel free to watch them. So we'll do some packet tracer and any questions? So now you know how to omit. You know why we need IPv6? We have three techniques if you want to keep IPv6, IPv4 together. How to omit leading zeros, rule 1, double colon. The format of IPv6, we have 8 blocks. The first 4 blocks is for the network. The other 4 is to assign to IDs, to PCs. The type of IPv6, we have 3 families: unicast, multicast, anycast. We'll focus more on unicast. Inside, we have 6, but we'll use 2 the most: link local and global unicast. And how to configure to an interface. Simple, that's all. So to identify a global unicast, it always starts with 2000 or 2001, the first block. To identify a link local, it starts with FE80, the first block always starts with FE80. We'll do some labs for that also. So you see here, if you see such IP start with 2001, it means it's a global unicast. But if you starting with FE80, it's a link local. You can read this one. Then how to configure, it's very simple. The first two blocks. So if you have an IPv4, we have two groups. The first 4 blocks for the network, the last 4 blocks for the interface, we know. And if you want some subnetting, we know. You take the first 4 blocks, the first 3 for the company, the fourth one is for the ID or subnet. If you want to copy the screen, you can copy, or if you want to read, you can read. In 5 minutes, we are done. We are almost done. Okay. For example, if you see that example down here, anything is green, it will identify the company. In purple, the subnet, and anything else we can assign to the PCs. Interface ID. And also, always when we start with, or when we deal with IPv6 in the global config mode, we need to activate it with our IPv6 unicast routing. It's something also we'll do a lot in our labs. Okay, we saw some examples of how to assign to PCs. In Packet Tracer, we'll do. This is an example of configuring link local, IPv6 address FE80, and we finish always with link local. No shutdown, exit.
Sorry, Max.
Yes,
I see in the terminal there is a config where it shows no shutdown. What is the purpose for the no shutdown?
always when you have an interface, you need to bring it live. So like we switch the light. So we switch so in your bedroom, if you want the light to be on, you switch on the light. Yeah, it's the same thing. You bring it live, else it's dead. So always for interface, you add the IP, you tap no shutdown. If not by
Okay.
default, it's shut down. So you bring it, so it's like you say, wake up and get ready to work. Wake up and get ready to work.
Okay, thank you very much.
Okay. So never forget no shutdown, never. When you configure interfaces. IPv4, IPv6, always no shutdown and exit. Okay, anything else we can do a bit later, not now. But what you need the most is what we did now. And we have some labs to do. Okay, guys, thank you very much. You can watch the recording again if you want to. We'll do some revision on Saturday. So Saturday, we'll do the packet tracer we started last Saturday. We'll finish it. We'll do again some examples of IPv4 and some example of how to configure IPv6. So Saturday will be a bit busy. It will help us to. Thank you very much, guys. If there is no questions, then have a good evening then.